Namaste bachcho. Welcome. Today, we're going to tackle a really interesting topic from your Unit 5, Magnetism and Matter. And that is the magnetic properties of materials. Now, I know, this chapter can feel a little confusing sometimes, but I promise you, after this simple explainer, you're going to find it super easy to understand and, more importantly, remember for your exams. Chalo, shuru karte hain.
Okay, so to get our minds working, let's start with a very simple question. A puzzle, you can say, something I'm sure you have seen in your own house. So have you ever thought about this? You take a powerful magnet, and an iron key just leaps towards it, right? But then you take the same magnet, and you bring it near a copper coin, and nothing. It just sits there. ऐसा क्यों? What's really going on here? What's the secret?
Well, bachcho, the answer to this little mystery isn't something you can see on the surface. Nope. We have to go deep inside the atoms of that iron and that copper. Because you see, it's all about the electrons and what they're up to. Now, this is the most important idea of this whole chapter, so listen carefully. It's not that some things are magnetic and others are non-magnetic. That's the wrong way to think. The real secret is every single material reacts to a magnet. The only difference is in how they react. Some are attracted, some are pushed away, some react really strongly, while others react so weakly you can't even notice it.
To make this super easy, just imagine how different people react to music at a party. First, you have the diamagnetic types. They don't like the music, so they plug their ears and try to move away. They are repelled, right? Then you have the paramagnetic people. They love the music. They'll dance as long as the song is playing. But as soon as the music stops, they stop dancing. They are weakly attracted, but only for a short time. And finally, you have the ferromagnetic fans. Oh, they love the music. They love it so much, they keep dancing and humming the tune even after the song is over. They are very strongly attracted, and they remember the feeling. Simple, isn't it?
But why do they behave like this? What's the science? Well, let's break it down. First thing to know, every single electron is spinning. And because it's spinning and it has charge, it acts like a tiny little magnet. We call this its magnetic dipole moment. Now, second point. In most atoms, electrons love to form pairs. And when they do, one spins one way and the other spins the opposite way. So what happens? Their magnetism cancels out. Perfectly. Zero net effect. But, and this is the most crucial part, what if an atom has some leftover unpaired electrons? Then their magnetism is not canceled. The whole atom now has a net magnetic moment and it starts behaving just like a tiny compass needle.
So now that we know the secret of paired and unpaired electrons, let's look at those three magnetic personalities again: diamagnetic, paramagnetic, and ferromagnetic. Pay close attention here, bachcho. This is a very, very important comparison for your exam.
This table really clears everything up. Look, for diamagnetism, the key is that all electrons are paired. This leads to a weak repulsion. Its magnetic susceptibility, which we write as the Greek letter chi, is small and negative. Next, paramagnetism. Here, the atom has unpaired electrons. This causes a weak attraction, so its susceptibility is small but positive. And finally, we have ferromagnetism, like in our iron key. It has unpaired electrons, yes, but also a very special exchange interaction that makes all its tiny atomic magnets line up together. This creates a very strong attraction and a very, very large positive susceptibility.
Now, let's zoom in on just the paramagnetic materials. There's a famous law for them called Curie's law. This is the exact formula from your NCERT textbook, so it's very important. It says that the magnetic susceptibility, chi, is inversely proportional to the absolute temperature T. Iska matlab bilkul simple hai. It just means that as you make a paramagnetic material hotter, it becomes less magnetic. Garmi badhegi, magnetism kam hoga. That's it. Let's just do a quick mental calculation. Imagine a material has a susceptibility of, let's just call it chi, at room temperature, which is about 300 Kelvin. Now, what happens if we heat it up and double the temperature to 600 Kelvin? Well, just look at the formula. Since temperature T is in the denominator, if you double T, the value of chi will become half. Simple as that. The material is now half as magnetic. See? These are easy marks waiting for you in the exam.
All right, now for a very important section, let's talk about some common mistakes. These silent killers that can silently steal your marks in the exam if you're not careful. So please listen carefully.
Okay, the first big mistake I see all the time in answer sheets is this. Students write that diamagnetic materials are just non-magnetic, that they have no magnetic properties. No, that is absolutely wrong. Please don't write that.
Diamagnetism is very much a magnetic property. It is the property of magnetic repulsion. And here's a mind-blowing fact. Every single material in the universe shows diamagnetism. Everything. So just remember this little hook. It's magnetic, just backwards.
And here is the second common mistake. Students think that, just like iron, if you bring a magnet near a paramagnetic material, it becomes a permanent magnet itself.
Again, that's incorrect. Paramagnetism is temporary. Just think of our music analogy. The moment the music stops, meaning the moment you take the external magnet away, all the atoms get jumbled up again because of the heat inside the material. The magnetism vanishes. Paramagnets forget their alignment. Only the ferromagnets remember it.
Fantastic. We've cleared up those confusing points. So now let's just take a step back, connect this to what you've already learned, and then summarize everything.
So you might be thinking, where does this fit in? Well, this whole topic of magnetic properties is a direct link to what you learn in chemistry in the chapter on atomic structure. That whole business of electronic configuration, s, p, df orbitals, it all comes down to one simple question. Are the electrons paired or are they unpaired? See? Physics and chemistry are talking about the same thing. They're deeply connected.
So, if you forget everything else, please just remember these key points for your exam. 1. A material's magnetic property depends completely on its atomic electron structure. 2. Diamagnetism means all electrons are paired, causing weak repulsion. 3. Paramagnetism means it has unpaired electrons, causing weak attraction. 4. Ferromagnetism is special. It has unpaired electrons plus a strong exchange interaction, causing very strong attraction. And finally, a great line to remember. Magnetic strength comes from the quality of alignment, not just the size of the magnet.
And now we can finally come back to where we started, to our first mystery. Why does the magnet pull the iron key but completely ignore the copper coin? After everything we've learned, we can now solve this puzzle.
And here it is, the grand reveal. It's actually so simple once you know the science. Iron is ferromagnetic. Why? Because an iron atom has 4 unpaired electrons in its d orbital, and they all cooperate and align together, making it strongly attracted. What about copper? Well, copper is diamagnetic. All its electrons are nicely paired up. It has 0 unpaired electrons to create any attraction. In fact, if you had a sensitive enough instrument, you'd see it's actually being very, very weakly repelled. And just like that, mystery solved.
So I'll leave you with one final thought to play with. We just learned that every material, including water, plastic, even you and me, has diamagnetic properties. That means everything is weakly repelled by a magnet. So, what if we could build a magnet that was so unbelievably powerful? Could we use it to push against everyday objects and make them float? Maybe even levitate a living thing? Think about it. That's a fascinating question for you to explore. All the best.